This is part 2 of our video where we're dealing with a quadratic expression that has, of course, x squared and y squared terms. It has an xy term, a cross term in here, and it also has a y term. So we know that this is going to involve a rotation of the axis based upon what you saw in the last two videos, and also some translation of the axis as well. Now, we should remind you that, first of all, the playlist for all the videos is at the website, digital-university.org. And what we're doing now, we're really relying upon the knowledge base that we established in videos 33, 34, and 35, where we talked about the principal axis of transformation, and then the last two videos, 39 and 40, where we dealt with rotation of the axis. Now, here, our quadratic expression can be written like this in matrix form. And then what we derived in the last video is that this equation, and this can be a 4 for our particular problem, this 4 can be written as, this equation gets rewritten in general form like this, where lambda 1 and lambda 2 are the two eigenvalues of our symmetric matrix. And what we're calling x prime and y prime really are the eigenvectors of our symmetric matrix. Those eigenvectors of any symmetric matrix are orthogonal, so the two eigenvectors it has, the two orthogonal ones it has, we call one of them the x prime axis and the other one the y prime axis. And then something we want to clarify from the last video is this. And again, how we go from here to here is what we derived in the last video. And we said that, again, starting with this equation in general form, having it like this in matrix form, and then deriving this equation that we did in the last video, where we made this substitution here, that x equals a Model matrix times an x prime. Now here then, the Model matrix, which are comprised of the eigenvectors of this, specifically the unit eigenvectors, the Model matrix is also the rotation matrix, and that we established in one of the previous videos. So here, having this in component form, we would have the components of vector x are x and y. The components of x prime are x prime and y prime. So this equals m with the x prime, y prime components. So here we had this. Now this is replaced with this. This replaces this. So we have then we will have dE times this, which is this. Now, this is a matrix. It's a 2 by 2 matrix. So what we have is we're multiplying it on the left by a row vector. And we'll demonstrate this in just a moment. What we have is this times the first row in this matrix plus this one times the second row in that matrix. And that's what we mean by D prime and E prime. It may have been confusing the way we had it in the last video. And again, we'll show in just a moment exactly what we mean here with a specific example. Now, with this problem, with this matrix here, we dealt with this in video number 40. We know what its eigenvalues are, and we know what its eigenvectors are. For that, it has an eigenvalue of 2, and a corresponding unit eigenvector of this. That's this line segment. And for eigenvalue 4, it has a unit eigenvector here. That's this line segment. And then extend them out. And here then we can imagine this line right here being the x-axis tilted. So stemming from the x1 or the first eigenvector of this matrix, we have the x prime axis. And same thing here. This is the second eigenvector corresponding to eigenvalue 4, and that would be the y prime axis, where our primed axes are just simply taking our unprimed axis and rotating them by an angle theta. And again, we did all discuss that in the last video. The point here then is we know what lambda 1 and lambda 2 are. This is 2 and this is 4, so we have 2 x prime squared plus 4 y prime squared plus, now let's go back to our general equation. D is 0. We have no x here. E is 8 times the square root of 2. So what we have here then is 0, the square root of 2. Then we have times the Model matrix. And the Model matrix is comprised from, of course, the eigenvectors of this matrix, specifically the unit eigenvectors. This is the first column. This will be the second column. So we have this 1 over the square root of 2 minus 1 over the square root of 2. And the second column is just 1 over the square root of 2, 1 over the square root of 2, times x prime y prime equals 4. And what we did right here, this is the Model matrix. What we did right here is just what we showed a couple of steps back, if we can find it now. You have too many papers here. Right here. This is this, so we have this times the Model matrix times x prime y prime. This is 0 for our problem. This is 8 times the square root of 2. And we want to have an 8 here. Let's make this bigger. So D is 0, so we have 0. E is 8 times the square root of 2 times our Model matrix times x prime y prime equals 4. Now, remember, when we multiply a matrix by a row vector, it's always on the left, and it is this first element times the first row, that's going to be 0, plus the second element times the second row. So here we're going to have, here is this 2 x prime squared plus 4 y prime squared plus zeros here, then this will be minus 8 and plus 8. That's a row vector, so we have 8 minus 8, 8. The first element times the first row, that's 0. The second element times the second row, the square roots of 2 cancel out, so we have minus 8 and 8 times this, x prime y prime equals 4. Okay, now we have 2x prime squared plus 4y prime squared minus 8x prime plus 8y prime equals 4. So here then we start with this equation, making the substitutions as we explained in the past videos. We end up with this equation. Notice there is no xy term, but here, so what we've done then is that we have, so far, we know that our xy axis has been rotated, but then on the x prime, y prime axis, so right now what we could do is this. We just really drew half of what our x prime axis are. We would also have this continuing on, and we would have this continuing on. So a rotation of the axis, the origin is still right here though. But now we look at this, and we see we have x prime terms and y prime terms. So on our new x prime, y prime axis, there's going to be a translation of the origin here. And to see exactly how that works, first thing we have to do then is go ahead and complete the square on this. And that's pretty straightforward to do. First of all, it looks like we can divide everything by 2. So this would be x prime squared. That will be 2 minus 4 x prime squared plus 4 y prime squared. And 4 divided by 2 is 2. So here then we have x prime squared minus 4x prime plus 2y prime squared plus 4y prime equals 2. Then when we go ahead and complete the square here, we have x prime minus 2 squared minus 4. That equals this. Then we will have plus 2 times y prime plus 1 squared minus 2. That equals this, equals 2. And then here we have minus 4 minus 2, that's minus 6. Bring that over there, that's plus 8. So let's make this an 8. Get rid of this, and get rid of this. And now we have this equation right here, or divide through by 8, and we will have this divided by 8. This will be divided by 4. We'll get rid of that 2. And this equals 1. So we have x prime minus 2 squared plus y prime plus 1 squared divided by 8 divided by 4 equals 1. That is the equation of an ellipse. Only now we have it like this. Now here, x prime minus 2, we can call that x prime prime. Let's see, x prime minus 2 and y prime plus 1 like this. Then we'll have x double prime squared over 8 plus y double prime squared over 4 equals 1. X prime is this, y prime is this. So let's just erase the board so we don't get distracted by that and see exactly what all this means. Okay, here we have the x prime, y prime axis, and we only drew half of it. We could have extended it all the way across like this if we wanted to. But here's y prime, and here is x prime. Now, we know that on the x prime axis, y prime is always 0. Excuse me, this is the x prime, y prime axis. Then we also have the x prime prime, y prime axis. Now, on the x prime prime and y prime prime axis, when we're on x prime prime, when we're on x prime prime axis, the y double prime is 0. And that happens when y prime equals minus 1. So here is y prime, it's 0. Here y prime is minus 1. When it always equals minus 1, that's the x prime prime axis, the x double prime axis right here. Now when we're on the y double prime axis, that will happen when this is always 0, and that happens when x prime equals 2. So here now, here is the x prime axis right here, and now we have to go to where x prime equals 2. 1, 2. It always equals 2, so there's the y prime axis right here. So again, let's go over this again. We have a double prime axis here. Well, let's just stop. We first began with an xy system. Then it got rotated into an x prime, y prime axis. Now we have an x double prime and a y double prime right here. And now we realize, well, when we're on, if we're going to consider this as an axis, then we're on x double prime. This is always 0. And that will always be 0 when y prime equals minus 1. So here's y prime at 0, here's y prime at minus 1. Draw a parallel line through right there. Y prime is always minus 1. That's our x double prime axis. Y prime always equals minus 1. Now, for the y double prime axis, when we're on that axis, this is always 0. And that will be 0 whenever x prime is equal to plus 2. So here's the x prime axis. We go a distance 1, go a distance 2, and right there then is the y double prime axis. So here then is the new origin. So what happened is that first the xy prime axis was rotated, but the origin was still there. Now it's been translated so that the origin is here. Now we go up to our equation, and we have y double prime over 4. So here we want to go out a distance of 2 and a distance of 2, and then here on the x double prime axis go out a distance. Here's the x prime prime axis. Go out our distance from the origin, square root of 8, square root of 8, and we tried to at least give a crude sketch then of what the ellipse would be on this double prime axis, where we had a rotation plus a translation. Okay, that's it for this video. Again, we really need to have a firm understanding of the principal axis of transformation and what the thinking that goes into that. And we had 3 videos on that. I think it was videos 33, 34, and 35. So if all this stuff is still a little bit hazy, please go back and review those videos then come back and look at these, and hopefully it will make more sense.